Hello, everyone. Hello, champions. Welcome back to Math Bison. Today, I'm going to show you the 10 secrets of number manipulations. Are you a math adventurer? Have you been struggling with your math in some ways? These 10 secrets will help you fix most of the problems that you have. Hang on and let us dive in a moment. Hello, welcome back. Yes, in today's video, we are going to be exploring top secrets of number manipulation. These secrets are going to help you. You need to pay attention and make sure you follow the video to the very end so that you don't miss a thing. The first secret that I'm going to teach you today is mastering your zeros. This secret is called the secret is called mastering the zeros. Mastering the zeros. So, what do I mean by mastering the zeros? To master your zeros is for you to know the right way to manage zeros in numbers, especially when you are doing simple, basic operations with numbers, be it small figures or large numbers. I have been in classrooms, I have visited classrooms where I see where I visited classrooms where I have seen even teachers teaching children to solve this question like this. For example, you have 3, 5 times 20, 35 times 20. 35 times 20 is what? Ask a young scholar 35 times 20. The first thing that comes to mind is, you see the person is frozen and he or she is like, can I get my pen? Can I get my pen? Why do you need your pen? I usually laugh and say, no, you don't. You don't need pen to solve this. You need to pay attention to multiplication when one of the numbers you're multiplying is actually a multiple of 10. If it's a multiple of 10, in this case, 20. If it's a multiple of 10, when I say multiple of 10, I mean numbers like 10, 20, 30, even 100. 100 is a multiple of 10, and 100 is also a multiple of 100. So 200, 300, and so on. And even 1000, 2000, these are multiples of 10 and more, lots more. And also, we have 20 here. So if you have 20 here, what do you do? How do you manage this? Instead of going, telling children or telling learners, young learners to do 35 multiplied by 20, use column method. Yeah, column method. 0 times 5, 0, 0 times 3, 0, 2 times 5, 10, carry 1, 2 times 3, 6 plus 1, 7. And you now say, okay, so now it's time for addition. And in our addition, you do 0 plus 0. There's a placeholder 0 here. That's 0. 0 plus 0 is 0. Then there's another 0 here. 0 plus 7 is 7. And our answer is 700. Why are you stressing your brain? Better way. You need to be smarter. You're working too hard. This is the hard way. You're working too hard. You need to work smart in mathematics. So what do we do here instead? Instead of that, we do 35 times 20. Just start with this. 35 times 2. At least if you don't know 35 times 2, you could just do 2 times 5, 10, right? 2 times 3, 6 plus 1, that is 7. Just transfer this 0 to the answer and you're done. So your focus is going to be on this 35 times 2. That is where you should put your focus. But of course, you're not going to forget that you have a 0 that you're just putting aside to be used in the answer. You have to pay attention to it as well. You don't have to forget it completely. So what do? 35 times 2 is 70. Just transfer this 0 down here. This makes life easier than this method. Another example, 36 multiplied by 10,000. And the child is like, oh, okay, let me get my pen. That's usually the very first thing you hear. Let me get my pen. Why are you getting your pen? You don't need your pen. All you need is what? Just do this. Focus on 36 times 1. 36 times 1. 36 times 1 is 36. Transfer all the zeros to the answer. There are 4 zeros. Just put it 1, 2, 3, 4. 1, 2, 3. And you have 360,000. This is an easy life. This is smart life compared to 1,000 multiplied by 36. Ha. I think I learned mathematics using this method. Terrible, I would say. 6 times 0, 0. 6 times 0, 0. 6 times 0, 0. 6 times 0, 0. Come on. 6 times 1, 6. 3 times 0, 0. 3 times 0, 0. 3 times the next 0 is 0. 3 times the next 0 is 0. Then 3 times 1 is 3. And it's time to finish. We now start adding. Column method, we place zeros to hold. Yes, zeros of placeholders. Zeros that are just placeholders. 0 plus 0, you have 0. 0 plus 0, another 0. 0 plus 0, another 0. 0 plus 0, another 0. 6 plus 0, 6. 3 plus 0, 0 plus 3 is 3. Then we now have our answer, 360,000. Can you imagine the amount of time wasted in this method? Can you imagine the amount of energy wasted? For goodness sake, won't the learner be frustrated already? The other reason why this method is a bad method is that the tendency to make a mistake is very, very high. It's very, very high because for you to pay keen attention from the very beginning of this 0, 0, 0, 0 is very, very slim. So it's not the best method at all. So you need to learn to master your uh, your zeros, how to manipulate zeros properly. The second secret that I'm going to share with you will be mastering your number line. Number, number, number lines. Number line. The number line, for some of us, we know what number line. If you know what number line is this is what we call number line. Is a horizontal line of is a horizontal arrangement of numbers having zero in the middle, and to the right we have +1, +2, +3, +4, +5, and so on. And to the left we have negative numbers: -1, -2, -3, -4, -5, and so on. Now, the number line is like you describing, just imagine talking about or describing the house of Mr. A on a particular street. You say that, okay, when you go down the street, two houses away is when you get to the junction or when you get to the blue roofed house, then you start counting like four houses away from the blue roofed house. Then you get to Mr. Johnson's house. That's fourth house. After the blue roofed house is Mr. Johnson's house. The same way we can picture our numbers when we are manipulating numbers. For example, you are doing quick addition and somebody tells you 7, okay, let's say 4 minus 2. It's just simply saying, okay, start at 4 and move backwards. So it's a minus. When you do subtraction, you move in the direction to the left. It's subtraction. When you're doing addition, you move in the direction to the right. So if you say 4 minus 2, we are saying that you should start at 4, then move backwards. How many times? Twice. That's 4 minus 2. 4 minus 2. Where did you land? Where did you end it? You're ending at what? 2. +2. So your answer is +2. Well, this skill might be a bit advanced for maybe children in lower primary, but a good teacher should still be able to introduce this to them and help them understand it. If you put it in a game, they can master it. Use the right method, any child could actually master the number line to an extent, to a reasonable extent. And that would be a good card for the child to use, a good card for the child or for the learner to use, in his or her mathematics journey. Now, the number line is also very helpful when you're dealing with algebraic expressions for the more advanced uh, learners. And sometimes when you're solving quantitative aptitude questions, the number line could help. And you always trying to visualize the number line and seeing the arrows, the loops moving on the number line could help you be more accurate in manipulating negative numbers as well. Sometimes when you say, okay, -4 plus 7 and plus 5, sometimes this can be confusing. To many, this can be confusing. I could just picture starting with at 4, -4, then +5 says I should move in the direction towards the right. How many times? How many steps? 5 steps. So we go 1, 2, 3, 4, 5. Where did you end it? After taking 5 steps, you landed on +1. So your answer is +1. This can be done easily by visualizing and not necessarily holding a pen. This is the second secret. The third secret you would like to, in fact, you will really enjoy this one, is breaking numbers apart. Breaking numbers apart. Okay, breaking numbers apart. How do we break numbers apart? A lot of time when I'm dealing with young learners and they are faced with operations like, okay, if you tell them 2 plus 3, they tell you 5. If you say, okay, 12 plus 3, some of them are able to tell you 15. If you say 22 plus 13, then it is time to start thinking. What are you thinking? It is still, this is still formed from this tiny set of numbers. It's just growing a bit. If you can pay attention to how this thing transforms to this, you will still be able to solve it without having to hold a pen to solve. 22 plus 13. The right method, instead of you thinking, okay, column method all the time, this column method has been abused. 22, 13, 2 plus 3, 5, 2 plus 1, 3, and you have 35. Why are you stressing yourself? It is easier for your mind to work this question by breaking, what do we call it? Breaking numbers apart. Break numbers apart. So how do I break numbers apart? I'm simply just going to do break numbers apart. I'm going to do 22 plus 13. Now let's work together. Let's put all the tens together first before the units. So I'm just going to do 20 from here because here is 20 plus 2 and here is 10 plus 3. 10 plus 3. So what you are doing after this breaking, you rearrange, put all the tens together. 20 plus 10 plus 2 plus 3. Your mind can easily manipulate 20 plus 10 to be 30, then 2 plus 3 to be 5. Then we have 30 plus 5, which is what? 35. The way I've done it here looks like a long thing, but it's not a long thing because if I just cite this number, my mind filters the 20 and the 10 as 30 immediately. And I know that I'm now left with only 2 and 3, which is 5. And my mind is going to add it together to just give me 35. So this is very, very helpful. In fact, you'll be shocked at what you can do with this skill when you are dealing with larger numbers. Larger numbers, like take for instance, you have 6,256 plus maybe 3,000 or let's say 319. Okay, it's easy for me to look at this and say 6,000. Okay, 6,000 plus here. I'm done. There's no thousand on this side. So 6,000 plus 200 plus 300 plus what? 50 plus 10. Yeah. Then plus 6. Then plus 9. So this is easier for me to solve. This is going to be easier for anyone to solve than going by the long column method. So what you can do, especially if you want to build your mental sum capabilities. your capacity to manage numbers, to manipulate numbers mentally without holding a pen. It's easy for me to go and say, okay, I'll just say 6,000 plus 200. That's 6,200. 6,200 plus 300. 6,500. 6,500 plus 50. 6,550. 6,550 plus 10. 6,560. 6,560 plus 9 is 6,569. Then plus 6. 6,575. 6,575. Let's check if this is correct. 6256 using your column method. 319. So here is 15. We have 7. We have 5. And we have 6. But you see, for me to do this, I have seen learners, you know, you tell somebody, oh, 6,256 plus 3,319. The person will start doing like this. You'll be seeing the person moving the fingers in the air. 6 plus 9, 6 plus 9, 5 plus 1, 7, 2 plus 3. By the time you get to the third column, you have forgotten the answers you got in the other one. But using this approach helps. In fact, you don't need to worry, because as you are going, you are not leaving any number behind. You are always repeating 6,000, 6,000, 6,500, 6,000. So everything you are picking is going with you. Till you get to the last number, you are ever repeating every last answer you got. This is why it's smarter to go this way, okay? Separating, breaking the numbers apart into what? Thousands, hundreds, tens, and units, using the place values. So you add according to place values. Use place values first. Place values of 1,000 should come together fast. Then the 100 should add to it, should join it. Then the tens, then the units. This is going to help you immensely in your number manipulation skills. Now, let's move to the next um, number manipulation secret. This one, I call it patterns and properties. Patterns and properties. Patterns and properties. What do we mean by patterns and properties? The way numbers behave when you are manipulating them is important for you to pay attention to them and understand it deeply. So, an example is having like 3 plus 5. We know that 3 plus 5 is 8. Okay, now in terms of ordering, the order by which the numbers appear before you added the two numbers. What happens if we switch and have 5 plus 3? Does it also give us 8? Yes. So this is what we call commutative properties of operation. Commutative, 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 commutative properties of operations. So what does this mean? It simply means that the order does not matter whether it is 3 plus 5 or it is 5 plus 3. You are always going to get the same answer. The answer is going to be 8. And these commutative properties property also applies to another operation, which is multiplication. We also have commutative property in multiplication. Take, for example, if I'm saying 2 times 4, I'm still going to have 4 times 2, and I'll still have the same answer. It's 8. So we can say that addition and what? Multiplication are both, they are both what? They are both commutative. They are both commutative. They are commutative. Now, does this happen all the time? It is also okay for you to understand that there are exceptions. Commutative properties does not apply to division and subtraction. It does not apply. You cannot say 10 divided by 5 equals 5 divided by 10. This will be super wrong. It is not commutative. Not commutative. Not commutative at all. So 10 divided by 5 cannot be equal to 5 divided by 10 because this one will give you 2 and this side will give you half or 0.5. So this left hand side is not equal to right hand side. So this is not true. Let's try subtraction. In the same vein, if I say 20 minus 7, I get 7 minus 20 are not the same. This is wrong. They are not equal because 20 minus 7 will give us 13, but 7 minus 20 will give us negative 13. Negative 13 and positive 13 are not equal. So left hand side not equal to right hand side. So subtraction is not. Subtraction is not commutative. So now the other property that you should know will be distributive properties of operations. Distributive, distribute, distributive, distributive, distributive property. What do we mean by distributive property? To distribute is to share, to make sure that something goes round. Now, it might not go round, but this one has to go round. Distributive properties is saying that if, for example, I say 3 times 4 plus 1, 3 times 4 plus 1, it is the same thing as we can distribute. 3 will multiply 4, and we also say 3 will multiply 1. So you are distributing the influence of these three, the product of these three. You are distributing it between what? 4 and 1. Distribute 3 times 4. This will give us 3 times 4 plus 3 times 1. This is going to give us 12 plus 3, which is what? 15. Now come to the left hand side. If we decide not to distribute and we choose to use our board mass and we focus on, let's say we are focusing on the bracket first. So I'm going to have 3 brackets 4 plus 1. 3 bracket what? 4 plus 1 is 5. 3 times 5 is 15. 15 equals 15. So left hand side equals right hand side. So this is distributive property of what? Operations, basic operations. So you need to understand this. This is helpful in also in at the basic level. This can help you solve um, simple multiplication, especially with maybe 2 or 3 digit numbers. For example, if I say 4 times 20, 20, 22, or let me say even 32, 22. So you can just do 4 times 20. So you can open this first and say 22 is 20 plus 2. Then you have 4 times 20, which is 80. Then 4 times 2 is 8. The answer will be what? 88. Well, the way I've done it, you might be thinking, oh, is this not a long method? No, it's not. In fact, it's the smartest method to solve this. And by using this method, you can easily solve this question or anything that is similar. Of course, I know it's easy for you to say, oh, for 4 times 22 is 88. Yes. But it's not just this figure alone. Any other number that is in this pattern, 2 digit numbers multiplied by 1 digit number, you can open it up and you solve like this. It is distributive. 4 we go, multiply the number in the 20th, the 10th place value, and also 4 we go again to the unit. A final example on this will be like having, where you really see it in action, is like having 3 multiplied by 262, like a 64. Let's say 64, yeah. So I could just go on in my mind and say, oh, okay, this will give me 3 times 200, yeah, plus what? 3 times 60, yeah, plus what? 3 times 4. This will give us, we have 600 plus 180 plus what? 12. I can now further say, oh, 600 plus 100, that's 700. 700 plus 80, that's 780. 780 plus 10, 790 plus 2, 792. If you are not sure, if you are in doubt, 600, 180, using your column method, you have 2, you have 9, and you have 7. But while you think that this is easier, you will find it difficult if you are not holding a pen. But this method is smarter because with constant practice, it gets to a time when everything becomes so easy. In fact, your mind is automated when you are solving with this method. And your accuracy is almost guaranteed, like 100% accuracy most of the time. Most of the time. So, this is the secret of what? Breaking numbers apart. The next secret is, oh no, this is the secret of patterns and properties, distributive and commutative. The next secret that we are going to discuss is called estimation over precision. Estimation. Estimation. Estimation over precision. What do you mean by estimation over precision? Estimation is a rough manipulation that you do which does not necessarily have to be accurate, exact. Precision has to be exact. If you have 21 plus 35, I can do an estimate and say this should be around, I should be around, I'll be, okay, let me make my 21 to just be 20, and let me have 35 to be 40. This should be around approximately equal to what? 60. Yes, this is an estimation. It is not the answer. I will tell you why it is important sometimes to do this when you're manipulating numbers. Now, by the time I do precision, precision is 21 plus 35. Assuming, sorry, this will be equal. Assuming I'm using the method I used before because I don't like the column method anyway. So I have 20 plus 30, that is 50. And 50 plus 1 is 51, plus 5 is 56. So we have 56. Of course, if you compare 60 and 56, they are very close. So my estimation is correct, and my precision is correct too. Now, why is it important for you to do an estimation before precision? This is an instance. I've worked with scholars where somebody will do a sum like this. A sum like 80 divided by 2, and the person will write 160. It sounds crazy. Yes, but this is it. This person wrote 160 because why? Because the person saw 80 divided by 2, but in his mind, or the mind is doing otherwise, is doing 80 times 2. But if you are doing first level estimation, if you give me 80 divided by 2, for goodness sake, I know that if I'm doing division, the answer must be less than this. The quotient cannot be greater than the dividend. It is not possible. So this is the first level estimation I can do. And based on this estimation, it will become a guideline for me that I'm going to follow. And that will also serve as a control for me not to make this kind of gross blunder. It's a big blunder. So it is always good for you to have an estimation. Of course, you might think, oh, why should I waste my time estimating? These are things that over time it becomes automated in your mind. You don't have to stress, you do it seamlessly. But when you start, you have to make an effort to imbibe, you know. But after you have used it over time, it becomes part of you. So I just see 80 divided by 2, and I'm like, oh no, okay, so that number must be less than 80. So if I now have 160, immediately I write, or I wrote 160, my mind will tell me immediately, will just blow an alarm that, wow, no, something is wrong. You quickly know that something is wrong. How can I have 80 divided by 2 and the quotient is bigger? No, it's not possible. So you have to look again. Then you now have 80 divided by 2, then you have 40. So this is why estimation before precision can help you to improve in your number manipulation. The next secret that I'm going to teach you will be playing with numbers. Sometimes, as part of when I teach children, when I work with scholars, part of our mental math session, I can say, okay, tell me, let's start with a number. I can give a number and say, maybe say 2. I say, okay, pick a number. The person says 2. And I'm like, okay, plus 2. He says 4. I'm like, okay, minus 3. doesn't say 1. I'm like, okay, times 7. It says 7. Like, okay, times 7 again. It says, or the answer now is 49. I'm like, okay, minus 9. It says 40. Like, okay, times 2. It says, or 80. Like, okay, minus 20. It says 60. Like, okay, divided by 3. It says 20. This is just playing with numbers. It might look like you are playing, but honestly, you are training your mind to be, to have that precision, to have precision. Sometimes we can put random numbers on the screen and be like, okay, how can you, I will put 1, 2, 5, and I'll ask you, how can you make a 10 from here? How can you manipulate this number so that you have a 10? Then there could be several trials, but something that looks good can be 5 times 2 and times 1. That will give me 10. Yes, I could say, oh, how can I have how can you have how can you have 12 from here? How can you have 12? So you can do 5 um, plus 1, then you have multiplied by 2, and you have a 12. 5 plus 1 is 6. 6 times 2 is 12. This is another way to, there are different ways you could play with number. Sometimes we also play with number by saying, okay, come, let's try, for example, um, in this secret playing with numbers. I can have, I could say, give me, it's also related like pattern. I could say, okay, give me all the numbers that sum up to 5. All the numbers that sum up to 5. And the person is like, okay, 0 and 5. Yes, gives you 5. Give me two pairs of numbers that sum up to 5. Okay. Then 1 plus 4 gives 5. 2 plus 3 gives 5. Then you continue. 3 plus 2 gives 5. And 4 plus 1 gives 5. Then 5 plus 0 gives 5. You see, these things are looking like, oh, what a child's play. But come on, these are the things that makes a champion. Sometimes after we do sums to 5, we can proceed to sums to 10. We say, okay, sums to 10. 10, and like, okay, 0 and 10, 1 and 9, 2 and 8. Yeah, you continue like that until you have 8 and 2, then 9 and 1, then 10 and 0. If you're done with that, we can say, okay, let's do sum to 20. Sum to 20. My students are always, especially the younger ones, they're always very happy. They're always enjoying this kind of activity, especially like part of your warm-up activity. Children enjoy this kind of playing with numbers. Now, we are done with playing with numbers and we're almost done. So um, the next secret of number manipulation is something I call Um, master use fact family. Okay, no, we use fact family or families. What do I mean by fact families? The fact families are actually simple. If someone says, if I give a random operation, let's say, let's take addition for example. We have 40 plus 5, and our answer is 45. Excuse me. 40 plus 5 is 45. These three numbers are actually families. How? They stick together. They stick together because they are families. How do they stick together? I can decide to bring 45 first. And I say, okay, you guys should swap or shift your places. If I bring 45 first, what's going to happen? If I say 45, then I can have 45 minus 5 equals what? 40. And if I say 45 minus 40, this is equal to what? Equals to, this equals 5. I use this fact to help learners who have challenges with, say, division. Yes, when you're teaching division, when learners have mastered their multiplication table and you're teaching division, which is actually the right order, you want to teach multiplication first before you teach division. If I ask you to read multiplication table of 2 or table of 5, and you say 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. Now, if I'm going to teach division, we only need to use this fact family, to teach the division. If I multiply 5 items by 4 and I get 20, what will I do? Something is going to happen when you rearrange the family members. So you're going to have 20 divided by 5, and it will give you 4. And 20 divided by 4 will give you 5. When learners are aware that this family exists, such that when they swap positions, the operation maybe from multiplication to division, we can get the other. The first number multiplied by the second number to get the product. When you swap, bring the product first, then you divide. Now we're having a quotient of 4. So this can help them in manipulation. And also, when you're solving quantitative aptitude, this always comes in handy. This comes in handy. So the next secret is will be master your multiplication table. Multiplication table. Multiplication table is one aspect of mathematics that some teachers do not pay attention. Some teachers do not pay attention to, and parents also feel that, well, the biggest trouble that a child or a learner has is going to be solved by some magician lesson teacher, who doesn't also know that multiplication table is the backbone of number manipulation. Now, the good thing is that we don't need math teachers to actually teach learners or to support learners on their math, especially when it comes to multiplication table. They don't have to learn everything at once. And to be strategic, what you need is not all the numbers. You just need like you just need table of 2, table of 3, all the way to table of 9. These are the basics, foundation of multiplication table. Table of 1 is not something crazy. It's a math fact. Any number multiplied by 1 is the same number. Okay, so we don't have to go 2 times 1, 2, 3 times 1, 3, 4 times 1, 4. Waste of time. But where things are really beginning to change is when you have 2, because numbers are not repeated, answers are not repeated. Now, all the way to 9, then 10 is easy, 11 is easy, and 12, because somehow you already have 2 times 12. 2 times 12, 24. You have heard 3 times 12, 36. So the 12s are already there all the way to 9 times 12, 108. This numbers table of 12 is already embedded, in the other previous tables. So you don't need to dwell too much on table of 12. Now, when a child is comfortable with this 2 to 9, then you can extend and say, okay, instead of extending this way to 10, 11, 12, you want to extend downwards. Okay, let's do 2 by 20, 3 by 20, meaning 3 times 1 all the way to what? 3 times 20. Then 4 times 1 all the way to 4 times 20. Especially when this learner, when this student is preparing for a math competition, they are usually more comfortable when you can take them, when you can push them this far. In fact, I've worked with students that could do table of the multiplication table by 50. We go that far sometime, it's just to stretch them and make them a lot more comfortable. So, but however, there are different opinions about how to learn or whether to learn the multiplication table or not. Some schools of thought believe that um, learners should not be made to memorize the multiplication table. Rather, they should understand that multiplication table is a continuous addition. Yes, continuous addition we know. Yeah, 2 times 3 is the same thing as 2 plus 2 plus 2. And they will go 2 plus 2 plus 2, maybe on their fingers before they get 6. Sometimes we say, oh, use skip counting. Skip count. Instead of 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8. Just skip count. So skip count is just 2, 4, 6, 8, 10, like that. So if you ask a child, 2 times 3, the child will go 2, 4, 6 on his finger before he gets to 6. 2 times 3 is 6. How? If you want to make life easier for yourself, my own school of thought is that you should commit the whole table of 2 to 9 at least. Commit it to heart. Memorize it. That is it. Yes, you understand how it is working. You understand how it's behaving. It's continuous addition. It's keep counting. Yes, but for easy retrieval, when you need it most, you're already having focusing on how to deal with something more serious. Your multiplication table should not be another thing you have to deal with when you are solving a bigger problem. It should come to you naturally, with ease, with so much ease. And the only way to achieve that is for you to commit it to heart. It might look like a big work, but sometimes it's not. Just consistency. Just keep repeating it like a habit becomes a habit. You repeat and repeat and repeat and repeat and repeat. After some time, it becomes part of you. That is it. Master your multiplication table. And if you want to get the best of it, just commit it to heart. And you will see that you will not have your accuracy will go up. Yes. And you will save your energy, you will save your time, the time spent doing little multiplications. And this is taking us to the final secret of number manipulation, which is reverse engineering. Reverse engineering. Yeah, this looks like a big grammar, but come on. We are just saying that you should go backwards. Reverse, like a vehicle. A vehicle goes in reverse. So, if for example, maybe a lot of time when we are solving quantitative aptitude, and you have, like for example, you have 3 plus 7 minus 2 um, equals what? Equals 8. Come on. If we now write this number and we say 3 plus a certain number and plus 7 minus a certain number, okay, maybe we now put an x here, equals 8. You don't need to go into long algebraic expressions and algebraic equation solutions. We could use reverse engineering and say, okay, you know what? We are reversing from 8. We will, instead of adding 7, we subtract 7 minus 7. This gives us what? 1. Now, instead of adding 3, we subtract 3. We subtract 3 minus 3. You see, what we are doing is that we are going backwards and we'll be doing the opposite of every operation that we did. Okay, so minus 3 will give us minus 2. Well, this number, minus x equals minus 2. Minus x equals minus 2. Honestly, if minus x is minus 2, I think I don't need to bother again to see that the only number that matches is what? 2. If I have minus x equals minus 2, this equals this, right? Minus equals minus. X should also equal 2. Yes, x should equal 2. So, but of course, in algebraic equation, we will do negative takes negative and would leave our answer to be what? X equals 2. This is reverse engineering. It is very helpful when you are doing quantitative. For example, a quant that gives you like this, and maybe there is a middle number. Maybe you have 3, um, and you have 2, you have 1. And it's actually 2 times 1, 2, then plus 3, 5. You know, when you just look at it, you'll be like, okay, how do I get a 5? 2 plus 3, 5. Depending on maybe if you have another sample that challenges or that proves this line to be otherwise incorrect. But if the pattern that is working is that you have to do 2 times 1, then you now answer your answer plus 3 to get what? To get 5. Then what if you are now giving you are giving 5, you're giving 2, you're not giving 1. Yeah, you're giving, this one becomes like a question mark, and you have 3 here. So what do? I need to use reverse engineering to solve this. The reverse engineering is that I'm going to do 5. The last thing I did to get 5 was that I added, there was a plus 3. There was a plus 3 that resulted into 5. I will do 5, 5 minus 3. I'll get what? 2. What we did to this one was that we multiplied by 1. Now I'll say 2 divided by 1. I'll get what? 2. That's the 2 here. But if 1 is not given, especially in this one, 1 is not given. I'll just do 2 divided by 2, divided by 2, and I'll get 1. The 10th one will be using grids, okay, visualizing with arrays. Visualize, visualize, visualize with arrays. What do we mean by arrays? Arrays are just arrangement of items in rows and columns. Okay, in rows and columns. Take for example, like a grid. If I have this, and this, I can say, oh, this is. Can look at it as a grid and say, okay, I have 3 rows. So I have 2 rows and 3 columns. Okay, 2 rows and 3 columns. Now, this is grid. It can help us to solve quite a number of questions, especially in geometry, when you're finding areas of rectangles and squares and similar figures. We can also use this visualizing with arrays to look at multiplication table. For example, having a 4 times 5, and you're like, okay, you need to picture it as, 4 in what? 5 rows. 4 in 5 rows. 4 in 5 rows. 4 times 5. 4 in 5 rows. It looks basic, but this can be applied in some very serious topics, like even matrix. Matrices, you can use it. Where you have 2 by 2 matrix, 3 by 3, 2 by 3, and so on. So use visualizing in arrays will also be a very good way to be at the top of your number manipulation. Okay, there you have it. From managing your zeros to all the way to what? Visualizing with arrays. You have the secrets to better number manipulation. There's a lot more to tell you about how to get ahead in your math. I hope that we will see you again in another video where we discuss another topic. Thank you for your time. See you next time. Bye.